In section 1.4, we've just got quadratic equations. So the only difference between section R6 and 1.4 is that when we have ax squared plus bx plus c, now it's going to be set equal. If it's not set equal to 0, you have to get it set equal to 0. So for example, if we have something like 8x squared plus 9x equals -2 minus x squared, what you need to do is you need to move it to the other side. So I'm going to move everything from the right side over to the left. So I'm going to add 2. When I add 2, we're going to make sure that it goes in standard form. And I'm also going to add x squared so that we have 9x squared plus, drop down the 9x because we didn't combine it with anything, and then put plus 2 at the end. And then now the whole thing equals 0. So this right here would be standard form, and everything is on the left side and set equal to 0. Now, my A would be 9, B would also be 9, and then C would be 2. So let's get into some actual problems that we solve. And as we go through the problems, if at any time you need to pause it and go back, please make sure that you utilize YouTube's pause and going back to rewind features. For the first problem, we have 4x squared plus 12x equals 0. So there's only 2 terms, and it looks like they're both divisible by 4, and they both have an x in common. So what we're going to do is GCF, that forgotten method. So I'm going to take out a 4x. So we write down 4x. And then let's go ahead and write down in parentheses x plus 3 left over. Now, because it's set equal to 0, here's where the key is. You're going to separately set 4x equal to 0, and then your other factor, which is x plus 3 equal to 0. Now, when I divide by 4, 0 divided by a number is 0. On, remember, on versus no, so therefore x equals 0. And then the other one, when I subtract 3 from both sides, we get x equals -3. So we've got 2 answers, 0 and 3. Number 2, we're going to do 3x minus 12 equals 0. So this one, it's linear, but you can also think about factoring out a 3. And when I factor out a 3, we're left with x minus 4, and then it's equal to 0. So we're going to separately set 3 equal to 0, and then my factor x minus 4 equal to 0. Well, 3 cannot equal 0. So unlike problem number 1, when there was a 4x right here, this is just a 3. There's no variable here. So we've got 3. It can never, ever equal 0. So we're not going to use that one. My answer is only x equals 4. Question number 3. We'll do 14 x squared minus 35x equals 0. So in both of these terms, I can GCF a 7 and an x. So you pull out 7x, and then inside of our parentheses, we put what's left over. So we've got 2x minus 5 equals 0. So we set 7x equal to 0. So again, divide by 7, divide by 7. I'm really liking the number 2 today. X equals 0. And then we've got 2x minus 5 equals 0. So I'm going to add 5 to both sides. So you've got 2x equals positive 5, and then divide by 2. So you've got x equals 5 over 2 is our other answer. So those are factoring. We just did some GCF problems. Now let's get into the next set. So we have number 4. So we're going to continue factoring. We'll do x squared minus x minus 30 equals 0. Just like before, we're going to go ahead and do -30 up top. Remember, this is a times c. We've got -1 right there. So I'm going to write down factors of 30. And we're trying to get to a -1. So I'm going to make the bigger number negative. And those are my factors. So we've got 5 and then -6. So we're going to go ahead and we can write down x plus 5, x minus 6. Now leading coefficient is 1, so I don't have to worry about dividing by 1 here. Remember, my friend drives red Mustangs, so we're going to set this equal to 0. And we're going to separately set x plus 5 equal to 0, and we've got x minus 6 equals 0. Subtract 5, so we've got x equals negative 5, add 6, and we've got x equals positive 6, and those are two of our answers. Number 5, we'll go ahead and do x squared plus 9x plus 20 equals 0. Make the x. We're going to go ahead and put 20 up top, 9 below. So we should be thinking 4 and 5. So we've got x plus 4, x plus 5. So again, this is two numbers that multiply to 20 and then combine to 9 equals 0. So we're going to take x plus 4 equals 0, then x plus 5 equals 0. So we have our final answer, x equals negative 4, and then x equals negative 5. Number 6. We're going to solve using the square root property. So in this problem, we'll start with x squared equals 17. And this is it. So what we're going to do from here is I'm going to square root each side. And when I deliberately square root, you have to put plus or minus, and this right here is super important. So we're going to write down plus or minus, and then we've got the square root of 17. Because 17 cannot be reduced any further, this right here is our final answer. Number 7. We'll do x squared minus 25 equals 0. So there's two ways that we can go about solving this. The first way is to use the fact that x squared is a perfect square and then 25 is a perfect square. So I put x first in both, 5 last in both. 1 gets a plus, 1 gets a minus, set equal to 0. And then we can separately set them equal to 0. We get x equals negative 5, and then x equals positive 5. So I could solve it that way. The other way to solve it is to take the x squared minus 25 equals 0, and then I can add 25 to both sides. And this is just using the reverse operations. And we can do that for this problem. So we've got x squared equals 25. And when I deliberately square root, check this out, we've got x equals plus or minus, the square root of 25 is 5. So right here, I have the plus or minus, which means that x equals 5 and x equals negative 5. Number 8, we'll do x squared minus 13 equals 0. Now, x squared and 13, those are not perfect squares, so we have to reverse the operation. So I'm going to start by adding 13 to both sides. So we have x squared equals positive 13. And when I deliberately square root, we have x equals, and this is important, plus or minus, and you cannot break apart the square root of 13. So this right here is our final answer. Number 9. We'll do x squared minus 24 equals 0. So again, neither of them are perfect, so we're going to go ahead and reverse the operation. So I'm going to add 24 to both sides. So we have x squared equals 24. When I deliberately square root each side, we've got x equals, this is plus or minus the square root of 24. Now, from here, you have to think, what are two numbers that multiply to 24 and one is a perfect square? And hopefully you're thinking 4 and 6. 4 is on our list of perfect squares from last week because the square root of 4 equals 2. So actually our answer is going to be x equals plus or minus 2 square root 6. And that's our final answer. Number 10, we've got x squared minus 28. So again, it's a binomial. So we're going to go ahead and add 28 to both sides. So we've got x squared equals 28. Now we're going to deliberately square root. So we've got x equals, that's plus or minus the square root of 28. And then once again, we're thinking about numbers that multiply to 28, and one of them is a perfect square. So look at the list the other day. 4 is the largest number that they both go into, that it can break down into. And so our final answer for this is going to be, because the square root of 4 equals 2, so you've got x equals plus or minus 2 square root 7. Now, the last part about today's lesson, number 14. We're going to start with x minus 4 quantity squared equals 12. So from here, what we're going to do is we're going to get rid of the exponent of 2 right now by square rooting each side. So we've got x minus 4 equals plus or minus the square root of 12. From here, you're going to get x by itself. So this entire lesson, you're solving for x every time. So we're going to add 4 to both sides. So we've got x equals 4 plus or minus the square root of 12. Now, some of you are going to go a little bit further with this because you know that the square root of 12 can split up into perfect square of 4 and then 3, and then the square root of 4 is 2. So you're going to say that x equals 4 plus or minus, that'll be 2 square root 3. So I am totally good with this answer, and if you can go further, this is the preferred answer. We'll try another one, number 15. So we're going to do x minus 2 squared minus 7 equals 0. This one's a little bit different because the 7 is on the left side. You must get this entire thing on its own to start with. So we're going to start by getting that by itself. So I'm going to start by adding 7 to both sides. So we've got x minus 2 squared equals 7. From here, we're going to deliberately square root so that I can get rid of the squared. So you have x minus 2 equals, whenever you deliberately square root, we have to put plus or minus, and then it's square root 7. And the last thing that you can do is add 2 to each side. And this is our final answer. Last problem, just to make sure that we know, number 16. So we'll do x plus 11 quantity squared equals 144. We're going to start by square rooting each side. Now, when we take the square root of 144, that becomes plus or minus 12. So we're going to have actually two answers. X plus 11 equals positive 12, and then x plus 11 equals negative 12. And we get two answers. X equals subtract 11, 1, and then x equals subtract 11, negative 23.